Okay, so today we're diving into a design pattern that's seriously clutch, especially if you're gearing up for those tough senior software engineer interviews.
Oh yeah,
The
absolutely.
builder pattern.
This one really sets apart the candidates who get it, those who really grasp those core software design principles.
For sure. And honestly, even beyond interviews, it's just a solid concept for building software that's, well, maintainable and extensible, all that good stuff.
Yeah, it's not just about making the code work, right? It's about how it'll grow, how easy it'll be to tweak down the line, all that big picture thinking.
Exactly. So the builder pattern, at its heart, is about separating the how of building something complex from the what it actually looks like in the end.
Right, right.
Like imagine you've got a blueprint for a house.
Okay, yeah.
That blueprint, it lays out the steps, right?
Yeah.
Foundation, walls, roof, you know the drill.
Yeah.
But with that same blueprint, you could build a super modern house, all clean lines, or a Victorian one with all the fancy details,
Hmm.
or even a log cabin. Totally different vibes.
Yeah. Huh. That's a good way to put it. Same basic process, but the end result, completely different.
Exactly. And that's the beauty of the builder pattern. So for this deep dive, we're going to break this whole thing down.
Shit is good.
Core concepts, the benefits, how it actually works step by step, and why senior devs should have this in their arsenal.
We're going deep.
Deep dive, for sure. So let's start with the basics. Why even bother with the builder pattern? What problem does it solve for us out in the coding wild?
All right, so classic example here, and it might sound a bit dry at first, but stick with me.
Okay.
Imagine you're building a program to read and convert RTF documents. Rich text format.
Yeah.
Sometimes you just want the plain text, no formatting, just the words.
Makes sense.
But other times you need to keep the formatting, for printing maybe, or displaying it nicely.
Right.
And then sometimes you might even want to turn that RTF into something interactive, like a text editor widget, something you can actually use.
Okay, so you've got all these different ways you want to use the same document.
Exactly. Now, if you tried to cram all that conversion logic directly into your RTF reader,
Uh-oh.
it would get messy. Fast. You'd have this massive program overflowing with code for every single output format, adding new options. Forget about it. You'd be breaking things left and right. And the code itself would be so tightly woven together that any little change could have like a ripple effect. Total nightmare.
Okay, yeah, I'm starting to see the problem here. So where does the builder pattern come in to save the day?
So the key here is to step back a bit. Introduce a middleman,
Okay.
a builder. This guy sits between your RPF reader, which we'll call the director in this pattern,
Okay, director.
and the final output, whatever that ends up being. This builder, it decouples things, gives you some breathing room. So instead of the director handling everything, it hands off the conversion job to this builder.
So the director, our RTF reader, it still understands the RTF format, right? Still does the initial parsing.
Exactly. It just doesn't have to worry about generating the final output anymore. It just tells the builder, hey, I found this piece of text, or here's a formatting tag, and lets the builder take it from there.
And this builder, it's not just one thing, right? It's more like an abstract concept, a blueprint for how to handle the conversion.
You got it. We call it an abstract text converter. It lays out the general steps for creating the output, whether it's plain text, formatted text, or a widget. And then for each specific output, you have concrete builders that fill in the details.
So like you'd have an ACID converter for when you just want plain text.
Exactly. It would ignore all the formatting stuff and just focus on extracting the words, the raw content. And it would provide a way to get that plain text out, maybe a getACID text function or something.
Okay, and then a text converter for those times when you need a nicely formatted document.
Yep. It would keep all the style information, translate it into text markup, all that good stuff. And of course, it would have a way to give you the final text output.
And for the interactive widget, you'd have a text widget converter.
Yeah, precisely. It would take what the director finds and use it to build a fully functional widget with all the bells and whistles. You could grab the final widget with a getTextWidget function, something like that.
So we've got our abstract builder setting the stage, and then these concrete builders taking care of the specifics. And we've got our director, the RTF reader, orchestrating the whole thing. But what about the end product? The thing we're actually trying to build, that's the product, right?
Exactly. The product is what gets built in the end. In our example, it could be an ACI text object, a text object, or a full-blown text widget object. It's the concrete builder's job to actually build this product, to put all the pieces together and make it work.
Okay, so how does this whole dance actually play out? How do these pieces work together?
So it starts with the client, the part of the system that wants to do the conversion. This client creates the director, our RTF reader, and then it picks the right concrete builder for the job. Like if they need plain text, they'd grab the ASCII converter.
So the client knows what kind of output it wants.
Right. Then, as the director is going through the RTF document, it keeps the builder in the loop. Whenever it finds something interesting, like a chunk of text or a formatting tag, it tells the builder, hey, deal with this.
And the builder takes that information and adds it to the product it's building.
Exactly. It does the conversion, assembles everything just right, and then once the director is done with the whole document, the client can grab the finished product from the builder.
So it's a step-by-step process, all guided by the director. Makes sense. So what do we gain from all this? What are the big advantages of using the builder pattern?
Oh, there are a bunch. First off, remember how the director works with the builder through an abstract interface.
Yeah.
That means you can swap in different concrete builders and the director won't even notice. It doesn't care what the product's internal structure looks like as long as the builder follows the rules.
So if tomorrow we decided we needed to output Markdown instead of text, we could just create a new Markdown converter and plug it in. No need to mess with the RTF reader itself.
Bingo. That's the flexibility we're talking about. Another big win is that it keeps your code nice and tidy. All the construction logic is tucked away inside the concrete builders.
So the RTF reader doesn't need to know anything about how the output is actually structured.
Exactly. And that makes it much easier to maintain because changes to the product won't break the director. And think about it. We could potentially reuse those text converters with a completely different document reader, like one for SGML.
Oh, that's smart. So you're not just building a one-off solution, you're creating reusable components.
Exactly. And the third big advantage is control. With the builder pattern, the product gets built piece by piece, with the director calling the shots at each step.
So it's not just a one-shot creation process. You have more fine-grained control over how things are assembled.
Exactly. This is especially important when you're building really complex objects where the order of operations matters.
Okay, so when we're actually implementing this pattern, what are some key things to keep in mind?
All right, so one thing is the design of that abstract builder interface. It needs to be flexible enough to handle all the different products the concrete builders might create.
In the RTF example, it seemed pretty straightforward. The builder just appends stuff to the product as it goes along.
Right, that's a common approach. But sometimes you need the builder to have access to things that were built earlier. Like imagine you're building a maze.
Oh.
When you create a door, you need to connect it to two rooms, right? So the builder needs a way to reference those rooms, even though they were built earlier.
Ah, so it's not always just a linear process.
Right. Same thing if you're building something like a parse tree, you build the child nodes first and then need to link them to the parent. So the interface needs to support that kind of back and forth.
Makes sense. Another thing that struck me is why the products themselves don't usually have a common abstract class.
Yeah, good question. In many cases, the products are just so different that a shared parent class wouldn't make much sense. Like an ASCII text object and a text widget object, they serve completely different purposes.
Yeah, I get it. Forcing them into a hierarchy wouldn't really buy you much.
Right, and since the client knows which concrete builder it's using, it knows what kind of product it'll get and how to use it.
Okay, so it's a trade-off. You give up a little bit of strictness for a lot of flexibility.
Exactly. Oh, and one more thing about implementations, specifically in C++GL.
Okay.
There's this idea of having empty methods as defaults in the abstract builder class.
I vaguely remember reading about that.
So the idea is that each concrete builder only needs to override the methods it actually cares about. If a builder doesn't need to do anything when the director says build a door, it can just inherit the empty default method.
So it's about reducing boilerplate code,
Yeah,
making the concrete builders cleaner.
exactly. Less code, less headache. All right, now, I know we've been talking a lot of theory here, so let's look at some actual code.
Yeah, let's ground this in something concrete.
So remember the maze example.
Vaguely.
There's this maze builder class, and it has methods like build maze, build room, build door, and get maze.
Okay. Yeah.
Now, in the base maze builder class, these methods don't actually do anything. They're just placeholders, defining the steps without any concrete implementation.
So it's like the blueprint we talked about earlier.
Exactly. Then there's this function called create maze that takes a maze builder object as an argument.
Okay.
Inside create maze, it calls the builder's methods in a specific order. First, build maze, then build room, then build door, and finally get maze to retrieve the result.
So create maze lays out the algorithm for building a maze, but it doesn't actually know how the maze is represented. It just talks to the maze builder interface.
That's the beauty of it. Now let's look at a concrete implementation, the standard maze builder.
Okay.
This class actually builds a simple maze. It has a variable to store the maze it's building, and its methods actually create the rooms, walls, and doors.
So it fills in the details of the maze builder interface.
Exactly. It encapsulates the whole internal structure of the maze. Now here's where it gets really interesting.
Okay, I'm intrigued.
There's another concrete builder called Counting Maze Builder. This one doesn't actually build a maze at all.
What does it do then?
It just counts the number of rooms and doors that would have been created if it were building a real maze.
Wait, what?
So its methods don't actually create any objects, they just increment counters.
So if you pass this counting maze builder to the create maze function,
It'll still go through the motions of building a maze, but instead of a real maze, you'll just get a count of its components.
that's wild. So the same set of instructions can lead to completely different outcomes depending on the builder you use.
Precisely. That's the power of separating the algorithm from the representation.
This whole concept is blowing my mind a little bit. So are there any real-world examples of this pattern in action?
Oh, tons. A classic one is the RTF converter in the ET++ framework. They use a builder to process text stored in RTF format, just like our example.
So it's not just a theoretical concept, it's actually used in real systems.
Oh yeah, big time. Another example is Smalltalk 80. They use builders all over the place.
Like where?
Well, their parser uses a program node builder to create parse trees. Classes use a class builder to create subclasses. Even their bytecode stream is technically a builder, even though it builds a byte array rather than a typical object.
So it's a pretty versatile pattern.
Very. And then you've got things like the service configurator framework in ACE, which uses a builder to construct network service components at runtime.
So it's used in all sorts of different domains. Okay, so how does the builder pattern relate to other design patterns we might know?
So the first one that comes to mind is the abstract factory pattern.
Okay, I remember that one.
It also deals with creating objects, but the key difference is that abstract factory focuses on creating families of related objects, and it usually returns the product right away. The builder, on the other hand, builds a single complex object step by step.
So abstract factory is more about providing a toolbox of related objects, while builder is about meticulously constructing one specific thing.
Exactly, and the builder pattern often works hand in hand with the composite pattern.
How so?
Well, the composite pattern is often used to represent the kind of complex object that a builder might create, like a parse tree or a UI component. They're like two sides of the same coin.
So to wrap things up, what's the big takeaway from the builder pattern?
I'd say the biggest thing is that it gives you this incredible flexibility and control over how you build complex objects. By separating the algorithm from the representation, you can create different versions of the same object using the same process, and you can change either part independently without breaking the other.
And that makes your code way easier to maintain and extend down the line.
Absolutely. And for anyone prepping for senior dev interviews, understanding the builder pattern is crucial. It shows that you're not just a coder, you're a designer. You're thinking about the big picture, about how to create systems that are robust and adaptable.
It's about showing that you understand those fundamental software design principles. So listeners, I challenge you to think about systems you're familiar with. Can you spot any potential uses for the builder pattern? Or maybe even places where it's already being used. Being able to talk about these concepts in real-world scenarios will really set you apart, both in interviews and in your everyday work.
For sure. It's all about connecting the dots, seeing the patterns in action.
So to leave you with a final thought, the builder pattern isn't just about creating objects, it's about creating possibilities. It's about having a unified process that can lead to a whole spectrum of outcomes. It's a way of thinking that can really elevate your software design.
That's a great way to put it. It's about empowering you to build better, more flexible software. And who doesn't want that?